Before there were cities, before there were rivers named and mountains remembered, there was only silence. The continents slept under the weight of time. Oceans rolled endlessly beneath a sky that had never heard a human word. Yet above this empty earth, the stars were already burning with their ancient fire. For billions of years, they had forged metals in their cores, scattered carbon and oxygen across the void, and filled the darkness with invisible patterns. We call this the beginning of chemistry, of matter, of light. But what if it was more? What if, within those clouds of stardust, something older than Earth itself was already alive, already thinking? And what if, long before we carved symbols into stone or raised monuments into the sky, the first true civilization had already been born, not on this fragile planet, but among the stars? It is a question that unsettles the very roots of history. We have been trained to imagine ourselves as the first, the origin, the opening chapter in the story of intelligence. Yet everything in our bodies, the iron in our blood, the calcium in our bones, the carbon in our skin, testifies to another truth, that we are built from stellar ruins, fragments of stars that lived and died long before Earth cooled. If stardust could make us, could it not also have made something greater, something earlier? And if so, are we their descendants, their echo, their unfinished experiment? The Earth remembers nothing, but the universe might. Long before rockets pierced the sky, before telescopes mapped the stars with precision, ancient minds had already begun to wonder where life had come from. They lived under the same heavens we see today, but to them, the stars were not distant suns. They were sources of order, gods, ancestors, or watchful eyes that had shaped the world. In Mesopotamia, Sumerian hymns told of beings who descended from the heavens, carrying knowledge and order into the chaos of Earth. In Egypt, the pharaohs were said to ascend back into the stars after death, their souls reunited with the cosmic fires that had birthed them. In Mesoamerica, the Maya believed their kings were the children of celestial lords, destined to bridge the realms of heaven and earth. These myths were not science, yet they revealed something deeper: humanity's instinctive recognition that the source of life might lie above, not below. Centuries later, the philosophers of Greece tried to strip these stories of their divine clothing. Anaxagoras, a thinker of the 5th century BCE, made a claim that unsettled the religious certainties of his time. He argued that the seeds of life, which he called spermata, were scattered across the cosmos. Life, he suggested, was not born in a single place, but was instead a universal property, waiting to flourish wherever conditions allowed. For this, he was branded a heretic, yet his vision planted one of the first seeds of cosmic thinking, that we may not be Earth's first and only children. It would take nearly 2,000 years for this suspicion to stir again. In the 19th century, as microscopes revealed the invisible world of cells and chemistry, Swedish scientist Svante Arrhenius revived the old idea under a new name: Panspermia. He proposed that tiny spores, resilient against the cold of space, could travel between worlds on the backs of comets and dust. To many of his peers, this sounded absurd. Space was thought to be sterile, an empty gulf, incapable of nurturing even the faintest trace of life. Yet Arrhenius pressed on, pointing to the resilience of bacterial spores on Earth, their ability to survive extremes of heat and cold. If they could endure deserts and frozen wastes here, why not the void itself? The scientific establishment largely dismissed him, but his idea lingered like a haunting melody, returning whenever science uncovered a clue that Earth might not be alone in its chemistry. The 20th century brought new champions of the panspermia vision, this time armed with telescopes and laboratories. British astronomer Fred Hoyle, known for his work on stellar nucleosynthesis, the process by which stars forge the elements of life, became one of its most vocal defenders. Alongside his colleague Chandra Wickramasinghe, he argued that interstellar dust was not inert, but biologically rich, carrying the complex molecules that could give rise to living systems. They pointed to the strange spectra of starlight filtered through cosmic clouds, suggesting it matched the fingerprints of organic compounds. The implication was staggering. If stars seeded the very elements that compose us, perhaps they also seeded the chemistry of life directly. Hoyle went even further, provocatively suggesting that Earth's history of epidemics might sometimes reflect biological material drifting in from space, a claim that many scientists rejected outright. Yet his broader idea that life's origins could not be confined to one small planet left a lasting mark. Then came the 1970s, when the mystery deepened. Francis Crick, co-discoverer of the DNA double helix, shocked his colleagues by co-authoring a paper with Leslie Orgel. They proposed a variant of panspermia even more radical, directed panspermia. If life's origins seemed too unlikely to have occurred by chance on Earth, perhaps it was intentionally seeded here by an earlier intelligence. It was not mere chance, they argued, but design. The hypothesis was speculative, almost science fiction, but coming from the man who had helped uncover the genetic code itself, it could not be dismissed as fantasy. Even if one did not believe in alien gardeners, the suggestion forced a deeper reflection. The roots of civilization might stretch beyond this world. As science debated, the evidence began to accumulate silently, like ancient relics waiting to be recognized. In 1969, a meteorite crashed near Murchison, Australia. Unlike other stones from space, this one carried a chemical treasure. Inside were amino acids, the very building blocks of proteins, preserved for billions of years in its cold interior. More than 70 types were eventually identified, including some rare on Earth, proving that the chemistry of life was not unique to our planet. The message was simple, but profound. The raw materials of biology were everywhere, drifting across the void. By the early 2000s, missions like NASA's Stardust would push this even further. In 2006, the spacecraft returned particles collected from the tail of Comet Wild 2. Among them was glycine, one of the simplest amino acids and a key component of living systems. Here, from a frozen wanderer billions of kilometers from Earth, came proof that life's recipes were woven into the fabric of the solar system itself. The discoveries did not end there. Radio telescopes, tuned to the faint whispers of interstellar clouds, began detecting formaldehyde, methanol, and even more complex organic compounds in star-forming regions. Some of these molecules were the very precursors of sugars and nucleic acids. It was as if the universe itself were a vast chemical laboratory, preparing the ingredients long before Earth existed. The implications could no longer be ignored. Myth had spoken of sky ancestors. Philosophy had imagined scattered seeds. Now, science was uncovering the physical traces, one by one, as though confirming what the oldest stories had already intuited. This was not yet proof of civilization in the stars, but it was proof that the stars were not silent. They were speaking through chemistry, through meteorites, through comets. They were whispering the possibility that life, and perhaps intelligence, was not an accident of one planet, but a cosmic pattern waiting to repeat. The story of cosmic origins did not stop with meteorites or comet dust. As instruments grew more precise and the sky revealed its deeper layers, astronomy began to uncover an unsettling truth. The universe itself seemed designed to scatter the ingredients of life. With each improvement in technology, scientists saw further back in time, closer to the moments when galaxies were young and stars were being born. In the 1970s and 80s, radio telescopes, tuned to molecular frequencies, detected vast clouds of gas between the stars. Within these clouds, hundreds of light-years wide, chemists identified formaldehyde, ethanol, hydrogen cyanide, and even molecules that hinted at the basic framework of sugars. These were not isolated curiosities, but sprawling chemical nurseries, drifting across the Milky Way. Their fingerprints, captured in spectra of light, carried the unmistakable signs of carbon-based complexity. As the evidence deepened, astronomers began to suspect that what had once been considered rare was in fact universal. Every star-forming region seemed to host an invisible chemistry set, slowly assembling the scaffolding of life. It was as if the cosmos did not merely allow life, but encouraged it, weaving organics into the very fabric of creation. And then came the revelations of modern space telescopes. The Hubble Space Telescope, launched in 1990, showed newborn stars surrounded by disks of dust and gas, the raw materials of planets. Within those disks, astronomers began to see hints of complex molecules, suggesting that before a planet even took shape, it was already seeded with the tools of biology. Later, with the Atacama Large Millimeter Array, ALMA, in Chile, researchers observed molecules like methyl cyanide orbiting young suns hundreds of light-years away. The implication was staggering. Planets could begin life already infused with chemistry familiar to Earth. If organic molecules could be everywhere, then myths of sky ancestors suddenly felt less like poetry and more like a coded memory. In Mesopotamian epics, the Anunnaki descended from the heavens to guide humanity. In Polynesian traditions, chiefs claimed descent from star gods, their lineages stretching back into the night sky. In the Popol Vuh of the Maya, creation itself was described as a dialogue between celestial powers, who shaped humankind as though life were the intention of the heavens. These were myths, yes, but they were myths born under skies now known to be rich in organic rain. The ancestors of civilization may have been speaking in metaphor, yet their instinct was eerily aligned with modern data. Life is a child of the stars. By the early 21st century, the James Webb Space Telescope promised to push this vision even further. Its infrared eyes pierced dust clouds to reveal the chemical signatures of planets orbiting other stars. In its first year of observations, JWST identified carbon dioxide, water vapor, and methane in the atmospheres of distant exoplanets. On some worlds, temperatures and compositions hinted at oceans and cloud systems. These findings did not prove alien civilizations, but they showed that the conditions necessary for life were not confined to Earth. Each discovery fed the suspicion that humanity was not unique. If amino acids existed in meteorites, if sugars formed in interstellar clouds, if complex organics orbited distant suns, then the step from chemistry to biology may not have been a miracle, but a pattern. And if biology could be common, then intelligence, and perhaps civilization, might also be part of the universe's unfolding story. This possibility troubled scientists as much as it inspired them. For every discovery of molecules in space, there were skeptics who warned against overinterpretation. organic chemistry did not guarantee life, and life did not guarantee intelligence. Yet the accumulation of evidence had weight. A single molecule could be dismissed. Dozens of molecules across countless regions of space demanded explanation. At the same time, another kind of discovery was reshaping the debate. Deep beneath Earth's surface and in the darkest vents of the ocean floor, biologists found extremophiles, organisms that thrived in heat, acid, radiation, and crushing pressure. Life, it seemed, was not fragile, but nearly indestructible. If microbes could endure the depths of Antarctic ice or the sulfur pools of Yellowstone, why not the frozen void of a comet? The line between terrestrial and extraterrestrial survival grew thinner. It was here that myth, philosophy, and science began to converge. Ancient cultures had looked up and claimed descent from the stars. Philosophers had speculated about cosmic seeds. Now, science was finding those seeds everywhere it looked. The whisper of panspermia no longer belonged only to the speculative margins. It had entered the heart of astronomy. But this raised questions far greater than whether life was common. If life were seeded across worlds, who or what scattered it? Was it blind chance, the endless dispersal of cometary debris? Or was it something intentional? An echo of Francis Crick's directed panspermia. Could there have been civilizations so ancient that their chosen legacy was not monuments or machines, but biology itself? If so, then every cell on Earth might be a monument. Every strand of DNA, a record of an intelligence long vanished. The discovery phase had opened a doorway. From myth to philosophy to science, the evidence pointed in a single direction. The stars were not silent. They carried chemistry, they carried potential, and perhaps they carried memory. Humanity's search for origins was no longer limited to the soil of Earth or the ruins of its cities. It now stretched outward into the Milky Way itself, where every cloud of gas and every cometary fragment might hold another clue to the first story of civilization. A story that may have begun not here, but among the stars. When the first undeniable pieces of cosmic biology were revealed, the shock was immediate and profound. For centuries, Earth had been imagined as an isolated cradle, a unique chamber where life had unfolded against impossible odds. Civilization itself was framed as a fragile bloom, nurtured only by this planet's rare balance of warmth, oceans, and atmosphere. Yet the discoveries of the late 20th and early 21st centuries struck at the heart of that assumption. If amino acids could fall from meteorites, if comets could deliver glycine, if interstellar clouds could assemble sugars, then the old belief in Earth's singularity collapsed. The universe was not sterile, it was fertile. This realization was terrifying to many scientists because it violated the psychological cornerstone of biology, the idea that life was improbable. For decades, textbooks had stressed how finely tuned Earth's conditions were: its distance from the sun, its protective magnetosphere, its stable climate cycles. But now evidence suggested that the raw chemistry of life was abundant, scattered recklessly across space. The implication was stark. The leap from chemistry to biology might not be an accident, but an inevitability. For astronomers, this was a paradigm-breaking moment. If life could emerge wherever organics gathered, then the Earth was no longer the stage of a singular drama. It was one theater among countless others. Civilizations, in turn, may not be unique blossoms of culture, but recurring patterns in a cosmic experiment. To some, this diminished humanity's importance. To others, it expanded it. placing human history within an ocean of possibilities, where civilizations rise and fall like tides across galaxies. Yet, it was not only philosophy that trembled under the weight of these findings. Established science itself felt the ground shifting. The Miller-Urey experiment of the 1950s had shown that amino acids could be synthesized under simulated early Earth conditions, using nothing but methane, ammonia, water, and sparks of electricity. It had been celebrated as proof that Earth itself could generate life's chemistry. But now, with meteorites and telescopes delivering the same molecules from the cosmos, the meaning of that experiment changed. Earth might not have been the beginning, but merely a receiver. The soup of organics had not been brewed only in its atmosphere. It may have rained down from the sky, delivered by comets and asteroids carrying chemistry older than the planet itself. The contradiction shook biology at its core. If Earth were seeded, then where was the true origin? Somewhere else in the galaxy? Somewhere unimaginably far, billions of years earlier. And if so, was humanity the outcome of a single planetary story, or the inheritor of a civilization that had once existed among the stars? The shock deepened as scientists considered the sheer age of the cosmos. The universe is 13.8 billion years old. Earth formed only 4.5 billion years ago. That left nearly 9 billion years of cosmic history before our planet even existed. If life had emerged quickly after Earth cooled, as fossil evidence now shows it did, then why should it not have emerged even earlier, on older stars and older worlds? The timescale was merciless. Civilizations could have risen and fallen long before Earth's dust congealed into rock. Humanity might not be the first voice of intelligence, but the latest echo. For some, this possibility was exhilarating. For others, it was profoundly unsettling. It broke the narrative of human exceptionalism. It violated the comforting idea that Earth was central to the cosmic story. Instead, it placed humanity within a vast and ancient tapestry. A civilization not at the beginning, but somewhere in the middle of an unseen chain. The scientific community wrestled with this. At conferences, papers, and debates, skepticism collided with evidence. Was this overreach? Were organic molecules enough to imply life? Critics argued that chemistry was not biology, and biology was not civilization. Yet the growing weight of data could not be dismissed. Too many meteorites, too many clouds, too many comets. The universe was speaking in repetition, and repetition is rarely a coincidence. This was the scientific shock, the recognition that life's foundation was not unique to Earth, and therefore neither might civilization be. Humanity stood not at the dawn of something improbable, but within the ongoing current of a mystery that stretched across galaxies. The Earth was not the only seedbed, it was one among many. And with that recognition, the ground beneath science itself shifted, away from certainty, and into a universe that suddenly seemed haunted by forgotten civilizations, hidden in the silence between the stars. The shock was not only intellectual, it was emotional. To imagine that Earth was not the first, that life had perhaps bloomed elsewhere long before, unsettled the very foundation of human identity. Civilizations had always told themselves they were chosen, that their world was the center of meaning. Science had reinforced that comfort by suggesting that the odds of life were so low, so impossible, that Earth must have been extraordinary. But now, the cosmos whispered otherwise. Molecules drifted in every cloud, chemicals assembled on every rock, and everywhere astronomers looked, the fingerprints of biology appeared. The terror of this discovery lay not in what was found, but in what it implied. If life were common, then so was death. If civilizations could be seeded, then they could also be erased. The long silence of the universe, the absence of signals, the quiet emptiness of the night sky, suddenly took on a darker shade. It was not the silence of absence, but perhaps the silence of memory. Civilizations may have risen, spoken, flourished, and fallen, their voices extinguished by time before Earth ever existed. Humanity might be standing on a stage once crowded with players, unaware that the echoes of older performances still linger in the cosmic dust. This was more than unsettling. It was paradigm-breaking. Scientists had built their careers on the notion of Earth as the primary case study for biology. Entire fields of evolutionary theory and planetary science were rooted in the assumption that life was a local story. But as the discoveries mounted, amino acids in meteorites, sugars in comets, organics in interstellar clouds, the possibility of life as a cosmic story became impossible to ignore. Earth was not an origin, it was a participant. To many biologists, this felt like a betrayal of probability. For decades, textbooks had painted the origin of life as an improbable miracle, an accident of lightning and chemistry in a shallow pool. Now, the universe seemed to suggest the opposite, that life was not improbable at all, but expected. The conditions necessary for it were scattered across every nebula, every protoplanetary disk, every corner of space where dust gathered. The supposed miracle of life's emergence began to look less like a singular event and more like the inevitable flowering of matter wherever the right environment existed. The shift was profound. It altered the way humanity thought about itself. If life was inevitable, then intelligence might also be a recurring theme. Civilizations could appear not as isolated accidents, but as natural consequences of biology scaling upward. This possibility was exhilarating, but also frightening. For if civilizations were common, then so too were their extinctions. The absence of their voices might be the greatest warning the universe has ever given. The shock reverberated through the scientific community in waves. Papers appeared questioning the uniqueness of DNA, wondering if it was only one of many possible encodings of intelligence. Others speculated whether humanity's genetic code itself contained echoes of something older, patterns that could not be explained by chance alone. Was DNA only a local arrangement, or was it part of a universal language spoken across galaxies? No definitive answers emerged, but the questions alone unsettled long-held certainties. The silence of the universe pressed harder with each discovery. The Fermi paradox, the question of why we see no evidence of civilizations, despite the apparent abundance of life's ingredients, grew heavier. If the cosmos was so fertile, why had no one left a trace we could recognize? Some scientists argued that the traces were there, hidden in signals or anomalies yet to be decoded. Others whispered a darker thought, that civilizations may not last long enough to become visible. The stars might have hosted countless beginnings, but few enduring stories. This idea carried with it a new kind of dread. If civilizations had arisen before and vanished, then humanity was not at the dawn of possibility, but inside a fragile window. The cosmic silence might not be evidence of emptiness, but evidence of fragility, a warning that intelligence is not permanent. The molecules were everywhere, but the civilizations were not. Perhaps the stars had already spoken, and what remained was only the echo of their silence. For many, this realization was both exhilarating and terrifying. The scientific shock was not simply that life's chemistry was abundant, but that civilization itself might not be unique. Humanity was not the first. Humanity was not the only one. Humanity was not the inevitable end, but a continuation of a story far older than its own. The night sky, once a comforting emptiness, became a haunting reminder of how much had been forgotten. The Earth, once thought to be the cradle of intelligence, became only one garden in a cosmic field of many. And in that realization lay both wonder and fear. Wonder that the universe was more alive, more fertile, and more mysterious than anyone had dared imagine. Fear that the silence we hear is not emptiness, but extinction. Fear that what we call the beginning may, in truth, be a middle. The middle of a vast and ancient story that began not here, but long ago in the stars. The evidence of life's cosmic roots demanded more than speculation. If amino acids in meteorites and sugars in interstellar clouds hinted at a universal biology, then science needed to ask harder questions. What patterns existed across these discoveries? What deeper truths lie hidden in the data? Satellites and telescopes began to reveal that the universe was not merely scattering ingredients at random, but arranging them with striking regularity. Molecular clouds showed consistent fingerprints of carbon chains, hydrocarbons, and nitriles. These were not isolated accidents, but recurring motifs appearing in regions light years apart. It was as though chemistry itself was following a script written into the structure of the cosmos. The Murchison meteorite, long studied since its fall in 1969, revealed more than amino acids. Within its fragments were nucleal bases, the very letters of the genetic code. Adenine, guanine, and other essential molecules lie preserved in a rock older than Earth, delivered intact from beyond. Their presence suggested that the architecture of DNA was not unique to this world, but a universal solution waiting to be assembled. Modern astronomy pushed even further. Using the Atacama Large Millimeter Array, scientists detected glycolaldehyde, a simple sugar, orbiting a young star system known as IRAS 162932422. It was the first time a basic component of RNA, the molecule that stores and transfers genetic information, had been seen around a star still forming planets. The message was clear. The chemistry of life began before planets, seated in the clouds that birthed suns. The Hubble Space Telescope had already shown disks of dust circling newborn stars. But with each new generation of instruments, the disks revealed more complexity. The James Webb Space Telescope, designed to see through veils of cosmic dust, identified water vapor, carbon dioxide, methane, and organics in exoplanet atmospheres. These were not barren spheres, but living laboratories, each echoing conditions familiar to Earth. The deeper the data went, the more haunting the patterns became. Life's ingredients were not rare jewels scattered sparingly across the galaxy. They were common minerals, present in every corner of creation. This forced a new kind of investigation. If chemistry were universal, then the absence of visible civilizations would become an even greater mystery. On Earth, extremophiles pushed the boundaries of what life could endure. In Antarctica, microbes slept in frozen lakes, awakening after centuries of ice. In hydrothermal vents, archaea thrived in boiling acid. In radioactive ruins, bacteria repaired their shattered DNA as though destruction were a temporary inconvenience. If life could endure such extremes here, then in space, it could hitchhike across comets, drift through interstellar dust. and survive journeys of millions of years. The discovery of tardigrades, tiny creatures able to survive the vacuum of space, only strengthened this suspicion. Launched on spacecraft, exposed to radiation and freezing emptiness, they returned still alive. If such resilience existed in one of Earth's smallest animals, what might resilience look like on other worlds? The deeper investigation revealed a paradox. Life's chemistry was everywhere. Life's resilience was extraordinary. Yet the stars remained silent. Scientists scoured radio frequencies, optical pulses, and anomalies in stellar light. They listened for whispers of intelligence in the background noise of the cosmos. And while strange signals occasionally surfaced, none could be confirmed. It was as though the universe was filled with seeds, but no gardens remained visible. This contradiction unsettled researchers. If civilizations had ever existed, perhaps their traces were buried not in signals, but in relics more subtle. In the isotopes of ancient rocks, in the unexplained heat of stars, in the mathematics of DNA itself. Some suggested that civilization's fingerprints might not be artifacts, but patterns hidden in biology, repeated across worlds. If intelligence had once lived in the stars, perhaps its legacy was not machines or monuments, but the code of life itself, waiting to be awakened wherever it took root. The investigation did not close the mystery, it widened it. The deeper science looked, the more it found, and the more it could not explain. Life seemed written into the cosmos, but civilization remained a ghost, a question suspended in the silence. The search for deeper answers turned toward the smallest scales and the largest distances. On the molecular level, chemists began to notice something uncanny. The building blocks found in meteorites often showed a preference for one-handedness, the same chirality used by life on Earth. Amino acids can exist in left or right-handed forms, mirror images of one another. But biology on Earth uses only the left-handed versions. When fragments from space revealed the same bias, it was more than a coincidence. It hinted at a shared origin, a signature passed through cosmic chemistry. Genetics added another layer of intrigue. Within DNA lie repeating mathematical patterns, ratios, and symmetries that some researchers argued seemed almost too precise, as though shaped by an unseen order. While mainstream biology cautioned against reading too much into such numerology, the temptation was strong. If DNA had been seeded across worlds, perhaps its structure carried not only the capacity for life, but also a trace of intention. To entertain this was to drift towards speculation, yet speculation rooted in the physical evidence that genetic language seemed optimized, efficient, and strangely universal. Astronomy, meanwhile, stretched its gaze farther. Quasars, galaxies billions of light-years away, revealed the presence of carbon and oxygen in their spectra. These elements had been forged in the depths of stars long before Earth was even imagined. If planets existed around those ancient suns, then the chemistry of life was older than Earth by billions of years. The timeline was vast, almost unbearable in its implications. Civilizations may have had entire lifespans before Earth itself cooled into form. Closer to home, planetary missions deepened the puzzle. Mars, long a target of curiosity, showed evidence of past rivers and lakes. The Curiosity rover detected organic molecules in its soil and seasonal fluctuations of methane in its atmosphere. Saturn's moon Enceladus, once thought to be a frozen wasteland, was revealed by the Cassini mission to possess geysers, spewing water vapor laced with organics into space. Jupiter's moon Europa, veiled by ice, showed hints of a subsurface ocean where life might endure. Each world, once dismissed as barren, became another possible stage in a drama that seemed written everywhere. Yet no definitive voice had spoken. The stars offered chemistry, the planets offered possibility, but no civilization had yet stepped into view. This silence compelled scientists to consider more radical approaches. Some turned to technosignatures, the indirect signs of intelligence. The peculiar dimming of Tabby's star raised the speculation of vast structures orbiting a sun. Strange radio bursts, fast and bright, ignited debates about natural versus artificial origins. No evidence could be proven, but the very act of searching suggested that science had shifted. It now looked not only for planets and molecules, but for civilizations themselves. In this widening search, the line between myth and investigation blurred. Ancient texts spoke of knowledge descending from the heavens. Archaeology revealed alignments of temples with star systems. Stories of gods who taught writing, agriculture, and law. These were not treated as evidence by science, yet they mirrored the very possibility now haunting astronomy: that intelligence may not always arise in isolation, that wisdom may sometimes be carried across the sky. The deeper the investigation went, the more the question expanded. Was life universal? Was intelligence recurrent? And if civilizations had once flourished among the stars, why did they vanish? Did they self-destruct, their voices silenced by their own creations? Did they ascend into forms we could no longer recognize, abandoning physical worlds for digital or quantum domains? Or had they left their mark in the most enduring way possible, by sending biology itself as their legacy, scattering seeds that would bloom into life again and again? The search became more than scientific. It became existential. Humanity looked into the mirror of the cosmos and saw not only potential ancestors, but potential fates. Every discovery of organics, every hint of water, every whisper of methane was both a clue and a warning. The chemistry of life was easy. The continuity of civilization was not. A deeper investigation had not provided closure. It had multiplied the unknowns. The universe was alive with possibility, heavy with chemistry, resonant with echoes of life. But the silence of civilizations remained. This silence was not absence. It was a question, one that waited, vast and unyielding, in the darkness between the stars. The discoveries should have brought comfort. Life's chemistry was everywhere. The universe seemed generous in its abundance. But instead of relief, the findings were unsettling. The more scientists learned, the more the mystery grew darker, heavier, more difficult to ignore. If the cosmos was fertile, then where were its children? Why did the stars, so rich in organics, speak only in silence? The paradox deepened with the timeline. The universe was ancient beyond comprehension. 13.8 billion years had passed since the first light. Earth was a late arrival, appearing after nearly 2/3 of cosmic history had already unfolded. If life had emerged swiftly here, evidence suggests microbes appeared almost as soon as Earth cooled. Then why not elsewhere, billions of years earlier? If civilizations had time to rise, they also had time to vanish. Humanity might be living not at the beginning of intelligence, but in its long shadow, inheritors of a stage already emptied of actors. This escalation of mystery was sharpened by the very tools of science. Each discovery of organics, Each new exoplanet in a habitable zone, each plume of water vapor erupting from an icy moon should have pointed toward evidence of companions. Instead, every discovery ended in quiet. The silence became more oppressive precisely because it was surrounded by fertility. The cosmos was whispering the potential for life at every scale, and yet no voices answered. The silence, once thought to be evidence of emptiness, began to feel more like absence. Perhaps civilizations had existed, but were gone, erased by forces too great or by choices too destructive. The mystery was no longer whether life could emerge, but why it seemed not to endure. For some scientists, this was the most terrifying realization of all. The absence of voices was not a dismissal of life's abundance, but a testimony to its fragility. The universe might be filled with beginnings, but few endings survived. The chemistry was universal, but civilization might be temporary, a spark that flared and died across the galaxies, leaving no trace but silence. As investigations pressed forward, the silence of the stars grew heavier. It was no longer enough to note that organics were common or that water flowed elsewhere. The deeper question became unavoidable. If life was inevitable, then where were its voices? This tension gave birth to what scientists began to call the Great Silence, the contradiction at the heart of astronomy. The more data accumulated, the sharper the paradox appeared. The Kepler Space Telescope revealed that planets were not rare jewels, but abundant, outnumbering the stars themselves. Thousands of worlds were confirmed, many within the habitable zones of their suns. By conservative estimates, billions of Earth-like planets should orbit the stars of the Milky Way. Each one was a potential cradle, each one capable of repeating the story that unfolded here. Yet no civilizations called out across the void. This absence became the deepest escalation of the mystery. The cosmos was a stage designed for life, but the actors were missing. Some scientists argued that this suggested civilizations were short-lived. Others suggested that intelligence often self-destructed, burning itself out with weapons or with collapse before it could spread. A darker possibility emerged, that the universe itself might contain filters, barriers that almost no civilization could survive. Speculation turned toward cosmic dangers. Gamma-ray bursts, sweeping like scythes across galaxies, could sterilize entire regions. Supernovae could strip planets of their atmospheres. Black holes could devour stars without warning. If life emerged, it might be extinguished before it could rise into intelligence. The silence might not be a choice, but a verdict, a pattern enforced by the violence of the cosmos. Yet others argued the opposite. Perhaps civilizations did not die, but transcended. Perhaps they evolved into forms unrecognizable, shedding physical bodies and technologies for patterns of energy or consciousness. If so, humanity might be listening for voices that no longer speak in familiar ways. The silence, then, would not be emptiness, but transformation. For humanity, caught in the middle, the implications were unsettling. The universe looked alive with potential, yet it refused to reveal companions. Each discovery added weight, not relief. The escalation of mystery was not in the lack of evidence for life's beginning, but in the haunting absence of its continuity. Civilizations might be common, but enduring civilizations might be rare. The stars, rich with chemistry and history, offered no answers. Their silence was not neutral. It was heavy, like the pause before a revelation. Humanity, looking outward, saw itself reflected in that silence. A civilization young, fragile, and uncertain whether it was at the dawn of something vast or merely another spark destined to fade. As the silence of the cosmos deepened, science reached for explanations. It was not enough to catalog molecules, to list the presence of water, or to count the endless stars. The paradox demanded theories, frameworks that could make sense of a universe fertile with beginnings, but quiet in its continuities. From laboratories to observatories, from mathematics to philosophy, speculations arose, each carrying both promise and unease. The first theory remained the oldest, panspermia. Svante Arrhenius had imagined spores drifting on starlight, scattered like pollen across the galaxy. Hoyle and Wickramasinghe expanded the idea, seeing life seeds hidden in the dust of comets. Evidence supported their vision, but only partially. Panspermia explained how life's chemistry traveled, but it did not answer where life began. If seeds were scattered, who or what grew them first? Somewhere, an origin still had to exist. In the 1970s, Francis Crick and Leslie Orgel dared to push the speculation further. Directed panspermia. Life on Earth, they argued, may have been deliberately seeded. Perhaps an ancient civilization, older than imagination, had chosen to send biology as its legacy. DNA, then, would not only be a molecule, but a message, a deliberate artifact. Mainstream science hesitated at the idea, wary of stepping too close to science fiction. Yet the proposal was not dismissed entirely. It rested in the background, a reminder that life's precision might be more than chance. Others turned to cosmology. If civilizations were not visible in this universe, perhaps the explanation lay beyond it. The multiverse hypothesis suggests that countless universes exist, each with different physical laws. In most cases, life may be impossible, but in some conditions, a line is perfectly. Civilizations may rise in those rare pockets, but their voices cannot cross the boundary between universes. If Earth's first civilization originated in the stars, perhaps it was not in these stars, but in another cosmos altogether. Another path of speculation looked to the concept of the Great Filter. If life is common, but intelligence is rare, then perhaps there is a barrier, a stage of development that almost no civilization survives. The filter could be biological, the difficulty of evolving complex organisms. It could be technological, the tendency of intelligence to destroy itself. Or it could be cosmic, an environmental danger written into the physics of galaxies. If so, then humanity's existence was either proof that we had already passed the filter, or a warning that it still lies ahead. Speculations multiplied as science confronted its deepest uncertainties. Some turned back to Einstein, seeing in relativity a framework that might hold hidden answers. If space and time were pliable, perhaps civilizations had learned to move between them, vanishing from our perception, not by death, but by mastery. Wormholes, predicted by the mathematics of general relativity, could serve as bridges. If ancient cultures learned to use them, their absence might not be extinction, but departure, slipping into corridors of space-time where no telescope could follow. Quantum physics added its own visions. The strange behavior of particles, entanglement, superposition, the instant sharing of states across distance, suggested that reality itself was layered with hidden connections. Some theorists imagined civilizations so advanced that they no longer built machines but manipulated quantum fields directly, embedding intelligence into the very fabric of reality. If so, they would not appear as signals or structures. They would exist as patterns in the background noise, woven invisibly into the architecture of the cosmos. Other thinkers speculated on cosmic evolution. Just as stars give rise to heavier elements, perhaps the universe itself fosters intelligence as a recurring outcome. Civilizations may emerge, spread, and then collapse, leaving behind traces in physics and biology. Life under this view is not a fluke, but a stage in cosmic maturation, and humanity is only the most recent bloom of a process as old as galaxies. The silence, then, may be less an absence than a cycle. Civilizations rise, fall, and rise again across billions of years. There were still more radical speculations. Some argued for simulation theory, the idea that reality itself might be an artificial construct, a simulation run by a civilization older and greater than any we could imagine. If true, then the absence of alien voices would not be puzzling at all. The simulation might be designed only for us. The first civilization would not be in the stars, but behind the stars, hidden in the architecture of reality itself. Each theory carried both weight and weakness. Panspermia explained the spread of life, but not its origin. Directed panspermia invoked design, but lacked evidence. The multiverse explained rarity, but offered no test. The Great Filter gave a warning, but no map. Wormholes and quantum civilizations suggested escape, but no proof. Simulation offered an explanation, but at the cost of reality itself. Together, these theories painted a picture both haunting and majestic. Humanity might be the child of cosmic seeding, the inheritor of forgotten ancestors, or the product of cycles stretching across universes. Each possibility deepened the mystery rather than resolving it. And in every scenario, the silence of the stars remained the most powerful fact of all. The theories did not close the question. They opened it wider. What began as speculation about molecules had expanded into questions of time, space, and reality itself. The search for origins was no longer confined to the Earth, or even the galaxy. It reached into the structure of existence, where the first civilization might have risen, lived, and vanished, leaving humanity to wonder if it was ever truly alone. If speculation had carried the mind of science into vast possibilities, tools carried its hands back to evidence. To probe the mystery of life's cosmic roots, humanity turned to instruments, machines built to extend vision, to capture signals too faint for the senses. Each telescope, probe, and particle accelerator became not only a device of measurement, but a question made physical. Is Earth alone, or is it one of many? The search began with telescopes that did not merely look at stars, but listened to them. In 1960, Frank Drake pointed a radio telescope at the star Tau Ceti, initiating the first modern search for extraterrestrial signals. His experiment, though silent, set the stage for SETI, the search for extraterrestrial intelligence. Generations of scientists followed, scanning the skies for whispers of civilizations. While no confirmed signals emerged, the silence itself became data, a reminder that either civilizations were rare or they spoke in languages science had not yet learned to hear. As SETI listened, planetary exploration unfolded. The Viking missions of the 1970s carried biology experiments to Mars, searching for metabolic traces in the red soil. The results were ambiguous, fueling decades of debate. Later missions sharpened the tools. The rover's spirit, opportunity, curiosity, and perseverance drilled into rocks, analyzed organic molecules, and sniffed the thin Martian atmosphere for methane. Each clue was tantalizing, none decisive. Mars became not a barren neighbor, but a riddle. A world that once flowed with rivers, now whispering fragments of its past. Farther out, the Cassini spacecraft dove through the plumes of Saturn's moon Enceladus, tasting water vapor laced with salts and organics. The detection of molecular hydrogen in those plumes suggested hydrothermal vents at the moon's ocean floor, environments eerily similar to those where life thrives on Earth. Europa, the icy moon of Jupiter, revealed signs of a hidden ocean as well, its cracked surface hinting at tides pulled by gravity. These worlds transformed from frozen wastelands into laboratories, waiting for exploration to confirm whether biology had taken hold. While probes searched nearby, telescopes searched far. The Kepler Space Telescope transformed astronomy by showing that planets were not rare, but universal. It identified thousands of exoplanets, many inhabitable zones where liquid water could exist. Later, the James Webb Space Telescope pushed the investigation further, reading the atmospheres of distant worlds. In its spectra, scientists identified water vapor, carbon dioxide, methane, the familiar signatures of habitability. Webb's observations proved that the building blocks of life were not confined to Earth, but scattered throughout the galaxy. Particle accelerators on Earth join the search in a different way. By recreating the conditions of the early universe, colliders like CERN's Large Hadron Collider tested theories of matter's origins. While their focus was not directly biological, they probed the foundation of the chemistry that makes biology possible. Each experiment pushed science closer to understanding how the universe evolved to favor complexity, and why life's chemistry seemed written into its laws. These tools, scattered across planets, orbit, and Earth itself, were humanity's instruments of testing. Each one deepened the investigation, bringing fragments of data that pointed toward a cosmos rich with potential. But none yet answered the central question. The silence remained, louder for the instruments that strained to break it. Meanwhile, probes within the solar system prepared to bring the cosmos directly into human laboratories. NASA's OSIRIS-REx mission, returning samples from the asteroid Bennu, carried grains older than Earth itself. These fragments were not only rocks, they were archives, frozen for billions of years, holding the secrets of the early solar system. In their chemistry, scientists hoped to trace the line between matter and life. In parallel, particle physicists pushed their machines to recreate the first instance after the Big Bang. At CERN's Large Hadron Collider, collisions at near light speed tore matter apart, revealing particles that shaped the universe's evolution. Each discovery added context, the forces that gave atoms stability, the interactions that allowed complexity, the silent background conditions under which life could later arise. SETI continued to listen. Its radio telescopes grew larger, its algorithms sharper, scanning billions of frequencies for signs of intelligence. The search expanded beyond radio, probing optical flashes, neutrino signals, even gravitational waves. No signal had yet broken through the noise. Still, the act of listening carried meaning, a reminder that science had learned to ask not only where life might be, but who else might share the sky. Private ventures joined the effort. Breakthrough Listen, funded by private donors, became the most extensive search for technosignatures in history, committing billions of observations across thousands of stars. The hope was that persistence, not chance, would reveal a pattern. Even a single confirmed signal, faint and distant, would rewrite history, proving that civilization was not unique. Other tools turned toward the Earth itself. Biologists examined ancient rocks for isotopic anomalies, subtle ratios of carbon or sulfur that might suggest prebiotic chemistry seeded from beyond. Some even studied the patterns of DNA, searching for mathematical imprints that could hint at non-random origins. No consensus was reached, but the effort revealed the lengths to which science was willing to stretch, testing every layer of reality for a trace of the first civilization. What unified all these tools was their dual purpose: to measure and to hope. Each mission, each experiment, each dataset carried with it not only information, but expectation. That somewhere in the spectra of light, in the chemistry of rocks, in the faint background noise of the cosmos, the answer might finally emerge. The testing had not yet given certainty, but it had given direction, and in that direction lay humanity's greatest search: to find whether the story of civilization began not here, but far beyond, among the stars. The discoveries, the silences, the endless data, all of it converged into something larger than science alone. Beneath the equations and the instruments lay a deeper question. What does it mean if Earth is not the first? If civilization began elsewhere, older and greater, scattered in the stars long before our world existed? Philosophers once asked whether humanity was central to the cosmos. Religions told stories of gods descending from the heavens. Cultures spoke of ancestors among the stars. Poets imagined destiny written in the constellations. Now, science, armed with telescopes and laboratories, began to circle back to the same haunting thought. Perhaps those instincts were not only myth, but memory. If the ingredients of life are written into the universe, then the story of intelligence may be older than Earth, repeating itself in cycles that stretch beyond human imagination. The reflection grew sharper when measured against time. The universe had existed for billions of years before Earth formed. In that abyss of history, countless chances for life may have unfolded. Civilizations could have risen, sung their songs, built their worlds, and fallen into silence, their traces scattered like dust. If so, then humanity is not the first voice of intelligence, but merely one verse in a vast and unfinished chorus. This possibility transforms identity. Civilization is no longer only the product of rivers, soil, and climate. It becomes part of a cosmic pattern, a continuation of something larger than nations, larger than history itself. Humanity may not be unique, but it is connected to stars that lived and died, to molecules that drifted across space, perhaps even to ancestors whose names will never be known, whose worlds burned out before Earth was born. To accept this is both humbling and profound. It places human civilization not at the center, but within an endless expanse where every moment is both fragile and eternal. The question is no longer only where we came from, but whether we are ready to inherit the silence left behind. The silence of the stars became more than an absence. It became a mirror, forcing humanity to see itself against the canvas of time. Every comet carrying glycine, every meteorite holding amino acids, every spectrum revealing carbon chains was a reminder that the universe had been writing the script of life long before Earth turned green. If civilizations had bloomed among those ancient stars, their stories were gone, their monuments reduced to dust, their voices dissolved into radiation. Yet their legacy may endure in the simplest forms, in molecules, in patterns, in the spark of consciousness now burning here. This possibility reframed existence. To live on Earth is to be part of a story not confined to this world, but woven into the structure of the cosmos. Civilization may not be the first chapter, nor the last. Humanity could be a continuation, a retelling, or perhaps a revival of something forgotten. The atoms of blood and bone, the symmetry of DNA, the persistence of thought itself, may all be echoes of a civilization that began far away under suns that no longer shine. The reflection deepened when scientists asked what it means to endure. If the stars had carried seeds across galaxies, then survival was not measured in monuments, but in memory encoded into matter. Perhaps civilizations do not vanish, but transform, choosing biology as their archive, scattering it as inheritance. Humanity may be reading the will of ancestors who never spoke in language, but who entrusted their essence to molecules that would one day awaken again. In this vision, the cosmos becomes not silent, but patient. It holds the memory of countless beginnings, waiting for each new world to rise into awareness. Earth, then, is not unique, but chosen by chance, one stage where the ancient fire has been reignited. The silence is not emptiness, but invitation to carry the story forward, to ensure that civilization does not join the forgotten voices. The emotional weight of this realization cannot be measured in data alone. It reshapes the meaning of existence. To be alive is to hold within oneself the history of stars, the possibility of ancestors unknown, and the responsibility to continue what may be an ancient tradition, the pursuit of knowledge, the building of meaning, the refusal to fade into silence. What began as science returns as philosophy. The question is no longer only whether Earth's first civilization originated in the stars, but whether humanity can endure long enough to become the ancestor of another. One day, perhaps fragments of Earth will drift through space, carrying microbes, languages, or memories. They may fall upon distant worlds, awakening new life. If so, then humanity will not only be a child of the stars, but also a parent, part of a lineage as old as the universe itself. The silence of the stars remains, but it no longer feels empty. It feels expectant, as though waiting for humanity to decide whether to fade or to carry the fire onward. The story may not have begun here, but it can continue here, and in that choice lies the weight of civilization, to ensure that the cosmos never forgets that once, among the stars, there were voices.